What do cats and dryer sheets have in common? Keep watching to find out. If you've ever been to a sporting event or served in the Civil War cavalry, you'd recognize that tune. It's a bugle charge. When we talk about charge, we're not talking about bugle charges, we're talking about electric charge. But how does that relate to cats and dryer sheets? In order to understand this, let's zoom all the way in on our cat, so far that we can see exactly what it's made out of. As we've learned in the past, all terrestrial matter is made of atoms. We know that an atom has two parts, a nucleus and the electrons that orbit the nucleus. The nucleus itself is made of two additional parts, protons and neutrons. You might also remember that electrons have negative charge, protons have positive charge, and neutrons are neutral. Additionally, like charges repel and opposite charges attract. This seems to make sense. You'll remember from circular motion that in order for an object to orbit another object, those two objects need to be attracted to each other. Now, remembering that protons have positive charge and electrons have negative charge, it seems to make sense that opposites attract. Now let's bring this back to our cat and our dryer sheets. Now that I've reminded you of electric charge and the parts of an atom, why do you think a dryer sheet will stick to a sweater after it's been in the dryer? What might have to happen in order for our cat to have packing peanuts stuck to it? It's time to introduce some equations so that we can understand how to calculate the force between two charged objects. This equation is known as Coulombs Law. Coulombs Law says that the force between two charged objects is proportional to some constant times the product of the magnitudes of their charge divided by the distance between those two charges squared. In order to make this a vector, we can say that the force points from one charge to another charge. Now let's break down this equation even more. K is some constant. Q1 and Q2 are charges, which are measured in coulombs. R is the distance between the two charges, and R hat is a unit vector that points from one charge to another charge. Now, if I know what the force is that charge 1 acts on charge 2, what can I say about the force that charge 2 acts on charge 1? I'll give you a hint. Our old friend Newton might have something to say about it. Another thing that we can ask ourselves is, what's the force on a charged object if there's more than one charge near it? In order to answer this question, we apply what's called the superposition principle. The superposition principle says that if you have two charges and want to calculate the force on a third charge, you can calculate what the force is from each of those charges independently and then add them together to find the total force. Let's remind ourselves how to add vectors and also find what the force is acting on a charge when it's near two or more other charges. Vectors are a very important concept in physics, and so as we begin to explore Coulomb's law, it's worth reminding ourselves how we can break vectors into components and how we can add two vectors together. Let's consider two vectors, R1 and R2. Where R1 has some component A in X and some component B in Y. Vector R2 is going to have some component C in X and some component D in Y. Let's see how we can write down these two vectors in component form. The vector R1 is going to be equal to some unit vector x hat times something plus some unit vector y hat times something. The unit vector x hat is going to be its x component. For vector R1, the x component is A, and the y component is going to be multiplied by y hat, and so that component is going to be B. Now let's look at R2. R2 also has x and y components, and so let's fill in what those are. In X, R2 is a distance C. In Y, R2 is a distance D. But we need to be careful here because the D for R2 is in the negative direction, so this is a negative. Now let's say we wanted to find some vector R3 that is going to be equal to R1 plus R2. Now in order to find what this vector R3 is, all we do is we add the x components of R1 and R2 and the y components of R1 and R2. So it's going to look like this. So we go x by x. So this is going to give us, this is a plus c times x hat, plus the y components, which are going to be b minus d. Okay? So this is how we add vectors. Now let's see how we can solve a problem using superposition principle and Coulombs law. So consider this arrangement of charges where we have some charge Q1 that is at a position 0b, so it's along the y-axis, and another charge Q3 that's along the x-axis at a distance a from the origin, and some charge Q2 that's at a position ab. We'd like to find what the total force is acting on Q2. So in order to do this, what we're going to need to do is we need to calculate what the force is from Q1 acting on Q2 and the force acting from Q3 to Q2, and then use the superposition principle to add those two forces together. Let's start by writing down Coulombs law. Coulombs law says that the force acting from one charge to another charge is going to be equal to K times Q1 times Q2 divided by R squared times R hat. Okay, so now I've given you this recipe for what all of these terms mean. We just need to pick off all of the terms in the problem and then evaluate them. So for the first one, I've actually already written what this force is. We just need to evaluate what the unit vector is and what R is. So we need to ask ourselves, what is the distance from Q1 to Q2, and what is the vector that points from Q1 to Q2? To find R is a little bit easier, so we say that R is going to be just this distance here. This distance is the distance A. So R is equal to A. Now, what is the vector that points, or the unit vector that points from Q1 to Q2? Well, this is the x direction, and so that unit vector, R hat, here is actually just x hat. So the force that acts from 1 to 2 is going to be equal to K Q1 Q2 over A squared times x hat. Okay? Now let's look at what the force is from Q3 to Q2. So the force from Q3 to 2 is going to be equal to K times Q3 times Q2 divided by the distance from Q3 to Q2. This distance is going to be B, right? Because we can see that we have this labeled B on this side. So this is going to be B squared. And then we want to know what the unit vector is that points from Q3 to Q2. And so that unit vector, this points in this direction here, is the y direction. And so this is going to be y hat. Now to find what the total force is, we can just add these two together. So F total is going to be equal to F12 plus F32. Okay? Now, you'll remember I asked you a question earlier about what Newton might have to say about these forces. So, for instance, we calculated what the force is acting on Q2 from Q1. What could we say that the force is acting from Q2 to Q1? Well, Newton's third law says that they should form an equal and opposite pair. So what we can say then is F12 is equal to negative F21. Okay? And this should seem to make sense, because say Q1 and Q2 are positive charges. Q1 and Q2 are going to repel each other. So the force that Q1 acts on Q2 is going to push it this way, and the force that Q2 acts on Q1 is going to push it this way.